important to know how to interpret. We don't say probabilities, we have no probability statements in here. Probabilities change. We want to have confidence in what we say. We want to make a statement and be a certain amount of confidence. This is a different concept than you guys know from probability. I see a lot of closing eyes in here already, and I just started talking. Yeah, I just started talking. Yeah, I'm tired too. I probably sleep less than all of you. I'm sure about that. Well, let me tell you, I go to bed around 11:30, 12 o'clock. I go to bed with my grandson, and then when my daughter comes home at 2, I go upstairs to my bed.
Oh, wow.
Yes.
What a grandma.
What a grandma. And the night before, I puppy sat at my son's house. So yes, so I went to bed about the same time. I only sleep 4 or 5 hours. But,
Wow.
yeah, so I should be the one going like this.
You have a great attitude.
I've never been a very good sleeper, ever. Okay, so the last part we need to do in this is that sometimes, and we didn't do one where we changed the sample size, but sometimes we notice that the sample size makes a difference in our intervals. When we change the sample size, the intervals change. So we want to have the right amount in our sample to make this work, to make this be realistic to us. And this is the only time that we find a sample size that we're allowed to find, that gives us the information to find the sample size. So you get this really nice equation here. And this actually comes from, God bless you, this comes from your margin of error one. Your margin of error says this. Take the ZC times the standard deviation divided by the square root of n. So we're going to transform this formula to get over there, because isn't this n stand for sample size? So if I want to get to the sample size, can I solve for n? So remember, this is like a fraction, this is n. So I'm going to just cross multiply this and get e times the square root of n is equal to zc times the standard deviation. I'm going to divide by e. You don't have to know how to do this, but I want you to know where this comes from. So I get the square root of n is equal to this. Close, right? And how do you undo a square root? You square both sides. So therefore, to find my n by itself, I will take, ladies, my zc, my standard deviation, my margin of error, and I will square that whole thing. That's where that formula comes from. We don't really have a lot of different formulas. They all use the same variables. So they're all just like transformations. I will give you this formula so that you don't have to transform it yourself. But I just want you to see where it comes from. Okay? Now, so to find your minimum sample size, and how do we know when we need to do that? Because they're going to say, find the sample size to estimate the mean. Now, the key to this is you'll get a decimal. We can't have a decimal for sample size. I can't ask 42.3 people. So always, always round up to the next whole number. Because technically, if I need a sample of 23.1 people, if I round down, I didn't hit the 0.1 yet, right? So I always got to go up to the next number. So if I get this, I will say I need 24 people. I can't have a 0.1 person. But if I lose that 0.1, I never got that far. So always round up. When it's unknown, when your data is unknown, we can use your sample standard deviation. But your sample has to have at least n is greater than or equal to 30. So let's try one of these. This is the last part of this. Hang in there. Okay. An economics researcher in example 1, way back to example 1, wants to estimate the mean number of hours worked by all grocery store employees in the county. How many employees must be included in his sample? How large should his sample size be if he wants to actually make this work? To be 95% confident that the sample mean is within 1.5 hours. So he wants to know how many. This is his sample size. So as soon as I know my sample size, I say n is equal to, I write my formula. I only need to know a ZC. I need to know a population standard deviation, and I need to know a margin of error. Now, your population standard deviation from example 1 was given to us at 7.9. We already knew this. This is from example 1. Does it say I need to know my mean? Not asking for the mean. So I need the ZC for a 95. So again, I could do my inverse norm, right? My ZC, because this is like this. Here's my 95. So I can do 1 minus 0.95 divided by 2. I could go to my chart, because I know I have a chart on your note page. Go to your chart on your note page and find out what your ZC is, since we found that number like about 5 times already. 1.96. And remember, we always keep it to positive. Our standard deviation, 7.9. What's this E thing? Margin of error. They didn't give me a margin of error. What is my margin of error in that sentence? What does margin of error do? It adds or subtracts, right? There's the key. Within 1.5 hours of the mean. So if this is my mean, within 1.5, can I go this way and this way for 1.5? If it's within, does it have to say to the right or to the left? So I say, there is my margin of error. Now all I have to do is plug this mess in. Make sure you don't put 95 in here. Make sure you put 1.96. And you guys that struggle with this calculator, this has to go in parentheses before you square it. If you put it in your calculator as this first, this times this divided by this, then hit enter, then hit the square. Or alpha, do your alpha key, but you have to put parentheses around the whole thing. Yeah.
Can you show the steps for going in the calculator?
Sure can. Sure can. There's a number of different ways to do this. Hopefully my calculator will be proper. You can put this in parentheses. You can say, just like it's there, put a parentheses down, then go alpha, I equal, and give it this mess. 1.96 times exactly the way you read it. 7.9. It didn't take my times. Thank you. Okay, drop down here. This is your 1.5. Come out of this parentheses. Put your other parentheses here. And now hit the square button. Just put it in exactly as you read it. And this will give you your answer. Now we got 106.557. I'm just going to put that in there. Another way you can do this is this way. 1.96 times 7.9. The order of operation says it'll multiply, then it'll divide. Divide by 1.5. Hit enter. Take this answer and square it. It'll do it that way too.
Can you also show how you get the ZC thing?
The ZC?
Yeah,
Yep.
the steps.
Yep. So we know that 95% confidence, 95 falls symmetric to the middle. So I need to find this ZC. So I need to know this area. So if this is 100%, these add up to 5, right? They share 5%. So half of 5, this would be 2.5%. So technically, if I do the inverse norm, I could look up 0.025 on my inverse norm and find this ZC. It's going to be the negative, but I'm just going to get the 1.96 and leave it as a positive.
How do you get the inverse norm?
So Okay. And we're going to let your calculator do all that subtraction. Go second verse, same way you did for your normal CDF, 3 inverse norm. And see how I put it in, John? Let your calculator do that. But key to this is these parentheses. So now when I do this, keep your 0 and your 1, standard normal curve, you want a z-score. I get the negative 1.96, and I just have to make it a positive. Now, watch what happens when I don't put these parentheses. A couple of you guys struggled on that test with parentheses in your calculator. If I didn't put these parentheses in, order of operations, does this. It does a divide first. It divides this, and then it subtracts it from 1. This is not going to work. My parentheses are really, really important. I don't get the right answer without order of operations. Now, rule of thumb, I can't use my real rounding results, and this one it works anyway, but I always have to round up. So I would want 107 people in my sample so that I would get a good sample information and be 95% confident that I will be within 1.5. This is when I set the margin of error. I want to know. Otherwise, my margin of error we figure out based on your sample size. This is when we set the margin of error and we kind of work backwards. We say, I only want to be within 1.5 hours. I only want to be within 3. I only want to be within 4. So we set the margin of error. So to get to that number, tell me how many people I need to sample. Now, if I change this, and if I'm within 2 hours of the mean, again, think of your number line. If this is my mean, I went out 2 hours here. Oh, I could go out 2 hours here. Isn't that my margin of error? Because it doesn't say margin of error. It says within. So this is my margin of error. So all that means is going to change is this right here. This is going to go to a 2. So if I don't want to be as tight in there, let's see what happens to my sample size. What do you think will happen to it? Will it increase or decrease? Increase? Increase what? I didn't change my confidence interval. I just changed my margin of error. I said instead of being closer here, I can be a little bit spread out more. So let's see what happens. I have this here somewhere. God bless you. Get closer. There it is. So I'm going to come over here, and I'm going to come back down to here. Whoops. It does this all the time, that maybe it's crazy. I think this side of my board actually works better for the calculator. All right, so I'm changing that to 2. Let's see what happens. Huh, it decreased. I dropped down quite a bit. So let's think about that. So originally I said, here's my mean. I want it to be within 1.5. Now I want to be within 2. Do I need to have as much confidence now? More confidence, wider. However, for my sample size, do I need that much more to get there? I gave myself more wiggle room by going from 1.5 to 2. It has the opposite effect of your confidence interval. So now I'm going to take this, I'm going to round it up, and I only need 60 people in my sample. Make sense? Everybody awake in here? I know Sarah and Olivia are. They talk, I can hear them. Okay, I'm still going to be close. Okay. I'm going to give you guys a book assignment. Yeah. I'll try to cut it down a little bit what I normally do. I don't think you'll stay awake long enough to do it all. There's your assignment. Please write this down. 305 to 308. Five, 8. I'm cutting it down. I'm not even giving you that much. 9 and 11, I like those. 13. 17 through 20 are matching. Well, I like 25. Whoa. Hang on. I'm back again. 25. 30. Whoops. 29. 33.
Doesn't seem like you cut it down too much.
You believe it or not, I cut it down quite a bit. 36. 45. I did cut it down quite a bit. I know. 50. But some of these are simple. Like all these up here are real simple. This is a matching. This is the only part you're going to work in. All right, so write those down. I'm going to have to write them down too. Otherwise, I'll end up giving the other kids too much. Did everybody write this down? What are you waiting for? Yeah. I said to the class,